Boom. The last question due Friday. Okay, so I'm first gonna do number 20, and then I'm gonna do David. I'm gonna do the last question from the last homework number 4, which is exactly the one we're going over. So my numbers could be different from yours. Most likely they will be, but the idea is that, oh yeah, number 20, right? It is the last one. Okay, great. Okay, so number 20. Number 20 for me, I have this. I got f of negative 3 comma equals 13, and then I got that f of 3 equals negative 17, right? And then it says what? Okay, it says that let f be a linear function and then find f of x. Okay. So I have a linear function. Do you guys recall what linear functions are? Linear functions have this form, right? mx plus b. So I have a slope and I have a y-intercept. Now, it seems as though there's not much here, but there's everything that you need. Everything that you need is here. It's just that you have to be able to interpret this. And what do I mean by interpret? Interpret what? It should be up now, guys. The review sheet. I don't know why it takes so much longer for Google to upload it. When I scheduled it for 10:45, it's like 5 minutes late, but it's okay. What you should start to make the connection is that f of negative 3 equals 13 means the following. It means that the x value is negative 3 and that the y value is 13. So in other words, I have the coordinates negative 3 comma 13. That's one of my coordinates. The other coordinate set of coordinates is this. When my x value is 3, my y value is negative 17. So in other words, they're asking you, find the equation of a line that has these 2 points in them. So it goes back to that question that we've done before a lot. So what the first thing I have to find now is what? Is the slope. What is the slope? y2 minus y1 over x2 minus x1. So I can write this as what? x1, y1. I can write this as x2, y2. So then I plug in, I get what? I get negative 17 minus 13 all over 3 minus negative 3. Negative 17 minus 13 becomes negative 30. 3 minus negative 3 is 6. Negative 30 divided by 6 is negative 5. So I found my slope. Do you see that? So the key here, guys, the key was to see the relationship between functions and coordinates. If you understand how inputs and the outputs of a function represent the x and the y coordinates, then you would get the answer. So now I have the slope, and now I want to find the y-intercept. So what I could do, guys, is use point slope form. Remember, we've been using this point slope form. But what we're gonna have to do is we can't leave it in point slope form. We have to change it into y slope intercept form. So what's the point slope form again? Y minus y1 equals m parentheses x minus x1. What is my slope? It's negative 5. Now what is my x1? I can just plug in x1 here. It's negative 3. And then what is y1? It's 13. Then I distribute the negative 5. I get negative 5, and this is a plus. So negative 5x minus 15. This is y minus 13. And of course, I want to solve for y, right? So I'm going to get y by itself. So I add by 13. I add by 13. And I get that y is equal to negative 5x minus 2. And of course, I'm going to replace the y with f of x because this is the function notation. And this would be my final answer. F of x is equal to negative f of x, negative 5x minus 2. So remember, I had to solve for y to write in slope-intercept form. Okay? Does that make sense? That's how we do the last question. So any questions about the last question here? Great. Oh, average rate of change? Average rate of change is really just the slope formula. So the average rate of change is just a slope formula. Are you particularly asking about something in the review sheet? I think the review sheet has one of those questions. So guys, make sure you look at the review sheet. And again, I'm opening this up to you guys. So whatever you want to go over, of course, I can't go over everything in this limited amount of time that we have. But is there any in particular question here that you have questions with on? Then please let me know. So the average rate of change is really just slope, but it's written in a very particular way. Let me just write this. Usually, right, y is a function of x. So we write as f of x of 2 minus f of x 1 over x2 minus x1. So average rate of change is really just slope, but we're applying it to functions. That's all it is. Okay, so Jalen says number 3. When you say number 3, are you looking at question number 3 under fundamentals? I'm assuming that's a yes, right? Okay, so let's look at fundamentals. Number 3. Number 3 is 3 over 4 minus 2/3 minus 5 over 6 parentheses squared all over 2/3 minus 3/4. Okay, so we have fractions upon fractions upon fractions that we want to see what this equals to. So the first thing I'm going to do is take this guy and take this guy. So the first thing is, what is 2/3 minus 5 over 6? Why am I doing this? Because remember, we're doing the parentheses first, order of operations. So how do we subtract fractions? Common denominator, correct. And what's the common denominator? We have a 3 and a 6 in the denominator. So the least common denominator, right, is 6. So I must multiply this by 2 over 2. And I get 4 over 6 minus 5 over 6, which equals negative 1 over 6. So that's the first fraction in the numerator. And in the second one, I got 2/3 minus 3/4. And again, I want to combine this with the same denominator. So what is going to be my common denominator for the second for the second difference of fractions. I have a 3 in the denominator, I have a 4 in the denominator. So what am I trying to make the common denominator? Anybody, how do you combine 2/3 and 3/4?
12.
12, right? 12 has to be the common denominator. So then if I do so, then what must I multiply this by? I must multiply this fraction by 3/3 and multiply this by 4/4. So then I get what? I get 8/12 minus 9/12. That equals negative 1/12. Correct? So now let's go back to our original expression that we're looking for. Now instead of writing 2/3 minus 5/6, I'm going to write negative 1/6. But this whole thing is what? Squared. Divided by negative 1/12. So far, all we've taken care of is the parentheses. Now I'm going to take care of the exponents. What is negative 1/6 squared? Well, negative 1/6, when I square it, becomes what? So negative 1/6, when I square this, is the same thing as saying negative 1/6 multiplied by negative 1/6. I'm multiplying this to itself, right? So what's negative times a negative? Positive. What's 1 times 1? 1. 6 times 6? 36. So the answer here would be 1/36. So the top here I have 1/36 divided by negative 1/12. Now I took care of that, right? Now I have to divide, I have to apply, after we apply parentheses and exponents, I need to multiply or divide. Well, here, what do I have? I have a division of two fractions. I have sorry, I have 1/36 divided by negative 1/12. So what does that entail? That entails for me to keep the top fraction and then multiply by the reciprocal of the bottom fraction. So this becomes negative 1/36 times negative 12. This becomes positive 12/36, right? But 12/36 is really what? 1/3. So really the final, we're almost there. The final answer is just really 3/4 plus 1/3. So again, same denominator should be what? Should be a 12. So the answer is what? 9/12 plus 4/12. Now I have the same denominator. I can add the numerators. I get 13/12. And this is my final answer. Pardon me. So this question deals with rational numbers, which are fractions, knowing how to multiply them, how to combine them, how to square them, how to divide them, how to subtract from them. So you should have this ability to apply operations upon rational numbers. Okay, so this is a good question to go over, number 3. Any questions about this? Okay, number 9. Samir, no, your exam will be exactly the same way that we've, so yeah, so for your exam, right, it's going to be on Google Classroom. I'm going to be expecting everyone to have their cameras on, pointing towards their workspace, whether it be at your desk, wherever you're doing your work on, and it will be on Google Classroom, and you'll upload it onto Google Classroom, and also upload it as a single PDF file, just the same way you were doing for your quizzes. Okay?
What will be the time limit for that?
It will be exactly the class period. So it will be an hour and 15 minutes. So the same length that we have for class is what you're going to be given for the exam.
And the number of questions, like how many number of questions we're gonna have?
Well, number of questions that varies from time to time, but it should be so the format is going to be like I think 4 to 5 questions, and each question is going to have multi parts to it. So it's going to be like question number one, and then you have A, B, and C. It's going to be something like that, something of that kind. But you should be have 1 hour and 15 minutes for an exam is going to be enough, or should be enough time to answer all the questions that you will have on the exam.
Do you have the answer like for the review set as well, or just the question?
So I plan on uploading the answers to the review sheet later today. So you
Okay,
have it later today on Google Classroom. I'll also post it.
okay, thank you.
Okay. Yeah. So number 9, right? We have A. Remember, this is a set, and the set for A is -3, -2, -1, 0, 1, 2, 3. And this is -1, 0, 1. Um, A intersect B. So remember, A intersect B indicates what? Is it a union or intersection?
Intersection.
Correct. And what is an intersection?
-1, 0, and 1.
Right. But on the bigger, what's the bigger idea? What is an intersection of two sets? It's the set that what contains?
The common numbers.
Right. It's everything that's in common between A and B. And so the only ones that are in common are -1, 0, and 1. So Jalen, it's the numbers that are the same. Okay, that's the intersection. Now, what would be the union? The union is basically saying, hey, what is everything in everyone, in every set? Just include everything into one big happy family. So when I find the union between these two sets, what would be the union? Well, the set B is in set A, so just A is everything. So it really just means A is everything because I'm including everything. Okay, so that's number 9. That was a quick one. What else? Functions number 13. So number 13. Under functions. So number 13 just asks, determine whether a function is a function or not, and determine the domain and range. Okay. David, yes, you have to have your cameras on for the test, like I mentioned before. So quizzes you don't have to, but tests you do. All right. So number 13, part A. So part A, we have like a wave-like function, right? We have something that looks like this. Up and down, up and down. Yeah, David, I just want to see your the place that you're working at. I don't necessarily I understand everyone has a different scenario at their homes at the moment. What helps is if you have like a virtual background, that kind of helps in that department, and you only see yourself in it, so that could help if that might be applicable for you. I'm not sure. Yeah. Yeah, this is not really outside. I'm not really outside, but okay. So how do we determine whether a graph is a function or not? We have to apply the vertical line test, right? So we apply vertical line test. So when we apply the vertical line test, obviously it checks out. So yes, the graph represents a function. Represents a function because it passes the vertical line test. Now, what would be the domain? And what would be the range? So what would be the domain of a function that keeps on going? You see the arrows, right? It keeps on going all the way to the right as as far as possible and all the way to the left as far as possible. So the domain are all the x values, and the x values would be all of what? Right. It's going to be all the way to infinity, positive on the right side, and all the way to negative infinity on the left side. So the domain would be what? Negative infinity to positive infinity. Now, what's going to be my range? My range are going to be all the y values. So the y values, if we consider that every box is only 1 unit, so it's going to be everything in between what? +1 and -1. So everything in between the y values here is going to be my range. So my range will be from -1 to +1. Okay, so that's part A. That's part A. Now what's part B? Well, part B, I have a circle, something that looks like this.
Hey, Professor, I have a question.
Yes.
For the range, why did you put -1 and 1 in the bracket and the domain is in parentheses?
Very good question. So, okay, so let's look at the domain first. So the domain is -infinity to infinity because of the fact that because of these arrows here, and because of the curve has a cyclic manner to it, we're gonna assume the fact that the graph here will also appear cyclic in this form forever to the right and forever to the left, because these arrows indicate that this continues on. So because that's the case, then the domain represents all of the x values, right? The domain, the x values are all of the x values from -infinity to infinity. And the reason why I use parentheses for infinity in particular is because I can never attain infinity. I only approach infinity. This idea of infinity is not like a destination. This just says keep on going type of deal. So the square brackets are only when when it's included. But this idea of infinity, if you really want to think about it, you never actually attain infinity, you approach infinity. Whereas the range, if you notice, the range, it's kind of like enclosed, right? These cyclic waves, they don't get above the one and they don't get below the -1. They're wrapped in, they're wrapped between it. And the reason why we include them with the square brackets is because at these points, right? At these points, the y coordinates are 1 and -1. So 1 and -1 are attained as the y value.
Oh, okay.
So if I put parentheses, I would say it's not attained, but that's not the case. It is attained in this graph. So therefore we put the square brackets to indicate that we include -1 and +1.
Okay. Thank you. I got it.
No problem. Now I'm going to apply the same thing here, right? Apply vertical line test. I'm just going to write it as apply vertical line test, VLT. So the moment I draw one, what happens? I get 2 points of intersection. If I get 2 points of intersection, then what do I say? Not a function, right? It's not a function because it fails. The vertical line test, it fails. And I can still find a domain though. I can still think about the domain and the range. Remember, the domain are just all the x values, the range are all the y values. So what are the x values? So one way to think about this is, what kind of box can I place this circle in, right? What kind of box is this? Like, what's the box that confines this circle perfectly? So then if you count just the, like, how far away are the endpoints here and how far away are the endpoints here? For on the horizontal perspective, right? Where are these points? If you notice, the farthest most point on the circle is what? Is 2, 1. So this here is 2, 1. And then to the left, the farthest most point on the left is what? -4, 1. So then do you see how the x values are everything in terms of the x-axis? In terms of the x-axis is everything between -4 and 2. So then my my domain is -4, 2, and I'm including -4 and 2. And then my range is everything in the y value perspective. So then what are these points? What's the highest point here on the y? And what's the lowest point here of the y coordinate? So then what's the highest point here? If you count, it's 1, 2, 3, 4, 4, comma. So it's -1, 4. And then the lowest point would be what? -1, 2. So it's -1, -2. So then it's everything in between, right? It's everything in between the y values. So it's going to be what? The range is going to be -2, +4. Does everybody see that? So to find the domain and range of a graph, whether it be a function or not, is kind of like trying to enclose a rectangle around this graph. And then the dimensions of my rectangle will indicate all the things that are in between the x values. So that's the range, that's the domain. And then the y values, everything in between the dimensions of the box vertically will indicate everything that's in between the y values. And then it'll tell me the range values and the range interval and the domain interval. Okay, so we took care of, what is this? Number 13. Now let's look at, Jalen says number 17, and then we'll do 18, 19. Okay, so number 17 from fundamentals. So number 17. So for fundamentals, for number 17, we have 2 minus 2x minus 5 equals -7. Now, this is an absolute value question. An absolute value question, we still have to solve for the absolute value first. So this is an absolute value equation. So the first thing is I want to get all the absolute value on one side and everything that's not absolute value on the other side. So this is negative 2x minus 5. This is -9. Then there's a negative in front. I can divide by a -1. And when I do that, I get absolute value of 2x minus 5 is equal to positive 9. Okay? So we have an absolute value equation. How does the absolute value equation, how do we work this out? Well, remember, absolute value, for example, the absolute value of 9 equals positive 9, and the absolute value of negative 9 equals positive 9 as well. So I have a positive version and a negative version for the inside. So that means that the inside, 2x minus 5 could be positive 9, or 2x minus 5 could be a negative 9. So for those two different scenarios, I have to solve for x, and that's going to be my solution. So I can add by 5, and I get 2x is equal to 14 divided by 2. I get that x equals 7. Here I can add by 5, I get 2x equals negative 4. Divide by 2, and I get that x is equal to negative 2. So I got that x equals negative 2, x equals 7. And then what I should do after I get this is I should check, just in case. You always want to check your answers, always. So x equals 7, I want to check my answers into the original equation, which would be 2 minus 2 parentheses, I will put it in a 7, minus 5. Does this equal negative 7? Well, I'm just going to keep on going. This is the question, right? This would be what? 14 minus 5. Does this equal 7, negative 7? Well, 14 minus 5 is what? 9? 2 minus the absolute value of 9. Does that equal negative 7? Well, absolute value of 9 is 7. So, absolute value of 9 is 9. 2 minus 9 does equal negative 7. So this checks out. So x equals 7 is true. And then check the other one. X equals negative 2. 2 minus absolute value of 2 times negative 2 minus 5 equals negative 7. 2 minus negative 4 minus 5 equals negative 7. 2 minus negative 9 absolute value equals negative 7. 2 minus positive 9 equals negative 7. So this is true. So my solutions are x equals, and then put curly braces, negative 2 comma 7, and close curly braces.
Professor, can you please show that -2, like the top one? Yeah. How that came? Like I did with another process. So I just got like 7x, but I don't understand how like -2.
How you get 7x?
No, how you get like -2?
So I got -2 because of the idea that this is my absolute value function, right? And so the inside function here could be positive 9, or it could be negative 9, correct? Because wherever I plug in here, right, this whole expression has to be a positive 9. Or it could be a negative 9, because the absolute value of a positive 9 is 9. Absolute value of a negative 9 is also positive 9. So that's why I have this plus and minus idea here. I have two different possibilities. The possibility is that the 2x minus 5, the whole expression is positive 9, positive. Then I solve for x and I get 7. The other possibility is that 2x minus 5 is not positive 9, but negative 9. I still apply the same idea that I did here. I solve for x. But when I solve for x here, I get negative 2 instead.
Oh, okay, I got you. Thank you.
Okay, so whenever you have an absolute value equation set equal to a number, you always want to see that the expression inside the absolute value could be positive of that number or could be negative that number, because the absolute value makes it always positive. Okay. Okay, and then the next one is 18 or 19 from linear function. So functions, right? Wait, it says, Sima, you said questions like 18 or 19 from linear functions? Do you mean fundamentals? Oh, homework number 4. Oh, I thought you were talking about the review sheet. Yeah, so let's just quickly do Yeah, this is one of those. I mean, for number 18 and 19 on the review sheet will be equivalent to seeing to doing number 6 or 7. No, actually, yeah, it's like doing number 11 or 12 on the review sheet. That's 18 or 19 on the homework. So I'll leave you the review sheet to do for yourself, so you guys have more practice. So if you look at homework number 7, number 4, and if you look at number 18, for example, yeah. So if I have a point 4 comma 2, and I have a line parallel to 3x plus y equals -3 as an example, right? The key word here is parallel. So the first thing I always want to find is the slope-intercept form. So I subtract by 3x, and the reason why I do that is because when I do that, I know my slope. I know my slope is -3. I know that a line that's parallel to a line that has a slope of -3 must also have a slope of -3. And now I have a slope and I have a point. So what do I use? Point slope. I use point slope form. So when I use the point slope form formula, I get y minus y1 equals m times x minus x1. So this is y minus, and again, this is x1, y1. So y1 would be 2 equals -3 x minus 4. I distribute the -3. Y minus 2 equals -3x plus 12. Add by 2, add by 2. And I get that y equals -3x plus 14. Right? So this line right here is the line that contains the point 4 comma 2 and is parallel to the line 3x plus y equals -3. Now I'm going to do the same exact thing. The only difference now is I'm going to apply the possibility that the point, I'm going to use the same point, 4 comma 2, but now the line is not parallel but perpendicular. So that's the only other scenario, right? That's perpendicular, and I'm going to use the same line, 3x plus y equals -3. And what do I know from the previous problem? That my slope is -3. However, it's perpendicular this time. So if my line is perpendicular to this line, then what would be the slope of the line that I'm looking for? It would be exactly. So this is -3 over 1. The negative reciprocal is the opposite sign of negative, which is positive, and I flip 3 over 1 to 1 over 3. And the answer is 1/3. Good. And now look what I have. I have the slope and the point. So then I'm going to use point slope again. Then what is point slope? Y minus y1 equals m multiplied by x minus x1. So this is y minus 2 equals 1/3 x minus 4. Distribute the 1/3. And I get that y minus 2 equals 1/3 x minus 4/3. Solve for y. I add the 2, I add the 2. And I get that y is equal to 1/3 x. And then what's minus 4/3 plus 2 over 1? Make the same denominator. So I get -4 over 3 plus 6 over 3, which equals 2/3. So the answer here is 1/3 x plus 2/3. And voila. All right. So those are those two questions, and very good questions. Definitely something to look out for. Anything else? Anything else on the review sheet, from homework, from quizzes, anything?
Review states number 16. Just want to review it.
Which one?
Number 16.
On fundamentals? On the review sheet, right?
Yeah, on the review sheet. Yeah, on fundamentals.
Okay. So number 16. Number 16 says write and solve and write solution set in set builder notation. So we have what's called a compound inequality. We have two inequalities at once. So the first inequality is 4 minus 3x greater than or equal to 7. And at the same token, I want 2x plus 3 is greater than or equal to 7. So I want to solve for x. Let me solve for x. Subtract by 4, and I get that negative 3x is greater than or equal to 3. Divide by negative 3, divide by negative 3, and I get that x is less than or equal to negative 1. You see that? So I solved the first inequality. Remember, when you divide by a negative number, you flip the sign of the inequality when you divide by a negative number. Now I'm going to do the same exact thing in terms of solving the second inequality. So I get 2x is greater than or equal to 4. Divide by 2, divide by 2. And I get that x is greater than, or what is it? Greater than or equal to 2. Correct? So now look what I have. I have two inequalities. And what I'm going to do is I'm going to graph them on the number line. So one of them says negative 1. I'm going to include negative 1 and shade everything to the left of negative 1. The other inequality says get positive 2, close circle positive 2, and shade everything in between. Shade everything to the right, I mean. So that's the graph. That's the graph of these two inequalities, right? But what does and represent again? Does it represent an intersection?
Intersection.
Yes, Emil?
Intersection.
Very good. This is the intersection. Now, if I say this is an intersection, then what does that mean about these two intervals? Is there an intersection? Is there an overlap?
No.
No. So if that's the case, what would be the final result of this? What would be the solution?
There is no solution.
There is none. And how do we write that? We either write that as a
No solution.
curly brace with nothing in it.
Oh, okay.
Right? This indicates no solution. So this is an example where the shaded parts are no overlap. There's no overlap. Because there's no overlap, there's no intersection. And this compound inequality has no solution.
Professor, I actually have a question.
Yes.
So, okay, so like, you know how usually regarding the quizzes, you have us complete those after classes?
Correct.
Is it going to be the same thing with Wednesday's exam, or how's that going to?
Oh, no. It's going to be the whole class period is going to be the exam.
From when we log on until 12 p.m. Okay.
Correct. So yeah, the exam will be 10:45 a.m. to 12 p.m. and that's it.
And will we have to submit it like the same way how we would for a quiz, like PDF?
Right. Except that now you would most likely have much more to scan, right? You would have like multiple pages.
Okay.
But again, I want it as a single PDF, so that's important.
Yeah. Okay. All right. Thank you.
No problem. Anything else? So this is good. This is good. A lot of review here. Can you do word problems next? Yes, of course. Which word problems would you like? Do you want the word problems like at the end of the page, at the end of the review sheet? Yeah, the word problems uh, for systems of linear equations, right? So we tackled one of them when we did linear equations. So number 3 here, this is the big one here, systems of linear equations. And we can do number 1. So again, it's all about reading comprehension really with the word problems and knowing how to translate words into mathematical expressions. So number 1, right? Part A, I should say. I don't know why I say number 1. But part A says at a movie theater, admission tickets cost $5 for children and $8 for adults. The receipts for one Friday evening were $2,500. The next day, 3 times as many children as the night before, and only half the number of adults bought admission tickets. Yet the receipts were still $2,500. Find the number of children who attended on Friday evening. So first is identify what is the quantities that you don't know or you're trying to figure out. What are those 2 quantities? Well, do I know how many children went on Friday? I don't. Do I know how many adults went on Friday? I don't. So then what do? I create these let statements and say, hey, let X be the number of children that attended the movies on Friday, and let Y be the number of adults that attended the movies on Friday. So you're all with me with this? So this is important. Identifying your variables. There's no way to proceed without knowing what you don't know. So that's the first thing. Clearly identify what is it that I don't know. I don't know the number of children and I don't know the number of adults that went on Friday. Okay, once I establish that, then I can set variables to them and then I can create equations. So what would be equation number 1? To figure out equation number 1, I need to read again the information here that will help. Well, what does it say that for on Friday? It says that the receipts, the total sales on Friday is 2,500. An admission ticket for children is how much? $5. And the admissions ticket for an adult is how much? $8. If only, right? Now it's like what, $20? So then what would be the expression for Friday total sales? Jasmine, you are correct. If I have X number of children and for each ticket it's $5, so then it would be a total of 5X amount for children. And then for the adults, since every ticket is $8 and I have Y tickets for adults, then the expression would be 8Y for the total number of ticket sales from adults. And if you add up the ticket sales from children and adults, then the total amount will be 2,500. Is that clear? So again, this is the ticket sales, the children ticket sales. On Friday. And this is the adult ticket sales on Friday. So great. I have one equation, but I need 2 because I have 2 unknowns. So then what would be the second equation? The second equation is a little bit weird because what does it say? It says that the next day, 3 times as many students attended that were children, and only half the number of adults that went on Friday went on Saturday. So equation number 1 is on Friday, and equation number 2 is on Saturday. So what would be the equation for the second equation for Saturday? $15x plus 4y equals 2,500. Very good, Tyler. Now, how did you get that? Well, let's do a little play-by-play. In this case, we don't have x students that are children on Friday for Saturday. We have 3x because we have 3 times as much as what we had on Friday. And then we don't have y number of adults on Friday that goes to Saturday, but we have half of that. So that's why we divide by 2. And the interesting thing is that despite that, I still get 2,500 at the end. And then I get what? Then I can simplify this and I get 15x plus 4y equals 2,500. So then what's my system? My system is 5x plus 8y equals 2,500. And then my second equation would be 15x plus 4y is 2,500. Okay, so I got equation 1 and I got equation 2. And now I can apply either the substitution method or the elimination method or the graphing method. But the best way is really to apply the addition method or the elimination method. So I'm going to apply the addition elimination method. So which variables can you, oh, you can also set them equal to each other, Jalen. It's just the issue with that is if you do that, and you'll see, if I do that, right? 5x plus 8y equals 15x plus 4y. So what you just said here is correct. The problem is, Jalen, that we have one equation now and we have 2 unknowns. The issue with that is that I cannot solve for one of the unknowns because the other one will depend upon it. So do you see how setting them equal to each other the way they are doesn't really help you find what x equals nor what y equals? So that's why we apply the elimination method. That's why it's always the prescribed way of doing it. So now I have to decide what do I solve for, x or y? If you want, you want to eliminate x or solve for x, pardon me. So I have to choose one, right? So eliminate x. So if I eliminate x, right, Tyler suggests, well, this is 15, this is 5. The LCM between 5 and 15 is 15. This is already a positive 15, so make this a negative 15. In order to make this a negative 15, I must multiply both sides, everything, by negative 3. And I get negative 15x minus 24y equals, and then of course I'm multiplying this by negative 3 as well. I get what? Negative 7,500. Then I get 15x plus 4y equals 2,500. Then I add, as the elimination method entails. Then I simplify or eliminate the x's and I'm left with negative 20y. And that equals negative 5,000. Divide by negative 20. Divide by negative 20. And what am I left with? I get that y equals what? Is it 250? So what did I just figure out? What is y? Y represents there were 250 adults that went to the movies on Friday. Right? But we don't want the number of adult tickets, right? We want a number of not adult tickets, but children tickets. So then how do I find that? I want to find X. How do I find X? Anybody? I got Y. How do I find X? Put Y into one of the equations. Very good. That's right. So let me use the first equation. 5x plus 8y equals 2500. So I'm gonna plug in Y. Plug in Y equals 250. Then I get 5x plus 8 times 250 equals 2500. And then what's 8 times 250? So I get 5x plus what? 2000. That's right. So it's 2000 equals 2500. Subtract by 2000. Subtract by 2000. I get that 5x equals 500, which means that x equals 100. So then, there were how many? There were 100 children that went to the movies on Friday. Okay? And that's how we do this question. So the hardest part of this question is setting up the equations, the two equations. If you're able to do that, then I hope that the method of solving system of equations is intuitive and simple enough that now you can solve any kind of system. And again, setting it up is probably the hardest part of these questions. All right, anything else? When do we get no solution in equations? Well, remember, we get no solution in equations when the lines are parallel. When the slopes of the lines are parallel. That's when we have two lines that never intersect, so therefore you have no solutions. When it comes to word problems, it's kind of not gonna be the case that you have no solutions in word problems. That it's gonna be very hard to create a word problem. Not that it's hard, but it's kind of there's no point of solving a word problem or creating a word problem that has no solution in it. So you said do number one for systems of linear equations. Yeah, there's a typo here. I'm gonna fix that. So there's two number ones for systems of equations. Do you want to do number solve by graphing or solve addition and elimination? The graphing one? So number one for the graphing. So for graphing, I'm gonna use a graphing paper for this. Square paper. Okay. So I'm going to draw the graph. And I'm given two equations. I'm given 2x minus 3y equals negative 6. And I'm given that 2x minus y equals 2. So what I would do is I would rewrite this, right? I'll get negative y equals negative 2x plus 2, divide by negative 1, divide by negative 1. And I get that y is equal to positive 2x minus 2. So what does that mean? That means that I have minus 2, but then I move up by 2 over 1, move up by 2 over 1, move up by 2 over 1, and this is my graph. Right? And this is the graph of y equals 2x minus 2. Now I'm going to do the same exact thing. So this is number 2 here. This is number 1. So for number 1, I need to do a little bit more work because I have more things to take care of. But again, I'm going to subtract by 2x. I get negative 3y equals negative 2x minus 6. Divide by negative 3, divide by negative 3, divide by negative 3. And I get that y is equal to positive 2/3 plus 2. So I got plus 2, right? Right here. I go up by 2 over 3. Let me draw this with a different color. So I got 2 here as my starting position, and then my domain. Sorry, there should be an x here. My slope is 2/3. So I move up by 2 over 3. Up by 2 over 3. And then I have this one here. And then when I graph, no, let me try that again. What do I have here? I have my intersection. And what's the point of intersection? It's 3, 4. And that's my solution. Makes sense? So so that's how we solve this is number system of equations number 1, graphing. Solving system of equations by graphing. Okay. Anything else? Anything else, guys? Anything at all? I know we've done a lot of I think we've done a lot of questions. Fundamentals, number 13. We already did number 13. Wait, did we? No, we didn't. Number 13. Oh, no, we didn't. Okay, good. So number 13, right? So I'm gonna write it here. So fundamentals, number 13. So we got 2x minus 1 plus 1 over 3 minus 3x plus 4 over 6 equals 5x minus 9. over 9. I want to solve for x. So for this, there's several ways. There's two ways you can go about this. Again, at the end of the day, I want to solve for x. I want to get x by itself. At this moment, I have two fractions on the left side and one fraction on the right side. One way to do this is to get rid of all the fractions. That's one way. But what I'm going to do is I'm going to combine the equation, the fractions in the left side of the equation first. So I must have the same denominator, right? In this case, I have 3 and 6. So then what I should do is multiply the top by 2 and the bottom by 2, right? So when I do that, I get 2 multiplied by 2x plus 1 over 6 minus 3x plus 4 over 6. This equals 5x minus 9 over 9. Now that I have the same denominators, I can combine the numerators and I can distribute this. This becomes 4x plus 2 minus parentheses 3x plus 4. And all of that divided by 6. Then I can distribute the negative 1. And I get that 4x plus 2 minus 3x minus 4 all over 6. That equals 5x minus 9 over 9. Then I can combine like terms even further. 4x minus 3x is x. 2 minus 4 is negative 2 over 6 equals 5x minus 9 over 9. Now, whenever I reach a point where I have a fraction equal to a fraction, what we do here is what? We call this cross multiplication, right? We can only do this when we have a fraction. One fraction equals one fraction. That's the only time we can cross multiply this way. And when we do that, we get what? X minus 2 multiplied by 9 equals 6 multiplied by 5x minus 9. Distribute the 9, distribute the 6, and I get 9x minus 18 equals 30x minus 54. Solve for x, subtract by 30x, subtract that 30x, add by 18, add by 18. So 9x minus 30x is negative 21. And negative 54 minus 18 is 36. Negative 36. Then divide by negative 21. So I get that x is equal to positive 36 over 21. I can further simplify this, divide by 3, and I get 12 over 7. So the answer is x is equal to 12 over 7. Okay. Any questions about this whole process here?
I have a question. When you're cross multiplying any number, any fractions, does it matter what side that it goes on, the left or the right?
What do you mean? Like
you know how you chose to put 9 times x minus 2 on the left side?
Yes.
Okay.
Do you think that the answer would be different if I had it on the right side instead?
No, but I'm thinking about different fractions also.
Yeah. So, but the one thing about equality, right? The whole aspect of equality is that the left side equals the right side. So I can swap that, no problem. So the reason why I guess I did this to be on the left is just that I see this on the left already. So just might as well just tag along the 9. And then I see this on the right already and just tag along the 6. That's the way I see it, but it doesn't have to be that. So if I put this on the left side instead and I put this on the right side instead, it shouldn't matter. It shouldn't affect the answer at the end.
Okay.
Yeah, it's just that.
Professor, I have a question.
Yeah.
Oh, I'm sorry.
Let
Yeah,
me
go
just
ahead.
say that
Yeah.
because x minus 2 and 5x minus 9 are already, you can think of it, they're already in the numerator, right? They're already above. I can just leave them there. That's one way to think about it. And I'm really just tagging along this 9 when I multiply it. I'm just really just tagging along this 6 when I cross multiply. But that's a good question. Yes, another question?
Professor, in that question number 3, 1, solved by graphing, you just did like, can we do there? When I was doing homework, it shows me a different way to do that. So we can do like, let's suppose like, when y is this, then x is going to be this. Like that way we could do the graphing. The answer will be fine.
Yeah, so the way that I guess the homework maybe the web assigned, so you start to see that there's more than one way of doing so, right? Like this is one way of graphing a line, right? You solve for y, you find the y-intercept, you find the slope, you use the y-intercept as your starting position, then you use your slope to find the next few points and plot them, and then you graph them, and then voila, right? That's one way. The other way that sometimes may be helpful is to find the x and the y intercepts for each line. So if you notice, the x and the y intercepts they were found. It's just I never mentioned them. I never labeled them. I just literally just plotted the y-intercept and then used the slope to find the next two. But you could have said, hey, if y equals 0, then what does x equal? Well, x equals what? -3, which is right here. That's going to be your x-intercept. When x equals 0, what does y equal? Y equals +2, which is right here. You draw these 2 points, you draw the line between them.
Okay, gotcha. Thank you.
And usually that's helpful, that x and y intercept way of graphing is when the equation of the line is a standard form. So when it's in standard form, it kind of gives itself to say, hey, find the x and y intercepts. Though you don't have to, because you can also solve it in terms of y and then have it this way. So it's up to you, really. It's up to your preference. Do you find it much easier to do x and y intercepts and that's it? Or do you find more familiarity with the slope intercept form? That becomes up to you. Okay. All right, so I'll stop the recording with this.